Hey, it's Joel and I'm here with
Robert.
Robert is awesome, knows a lot about RC stuff, knows a lot about batteries, and that's great because we've got an OpenRC F1 update. We're going to talk about it here on 3D Printing Nerd. There you are, welcome back. So with the OpenRC F1, I've had a lot of people really interested in the progress on this, and it's been slow, but that's because it's been awesome. And Robert is awesome because he has put this all together. So Robert is going to give us a tour of what's going to enable the OpenRC F1 to hopefully go really fast. Hey, Robert.
Hey.
What's in front of us? Let's start, well, where do you want to start?
So let's start with these.
What are these?
These are the motors, two, that are going to power the Open F1 RC car.
This is huge, right?
It is.
I mean, I've had RC cars before, and the motors that power these are nothing like this.
Right. So these are designed for 1/5 scale RC cars.
Meaning?
So 1/5 of the real size of a a real car. And due to the weight of the printed car, we're actually going to end up using two of them.
That's insane. Because if one is already going to power a 5th scale car, how much is a 5th scale car usually weight-wise?
So these motors are usually rated for somewhere between 25 and 35 pounds each. And
a single motor.
A single motor.
And that will propel it at what?
Some of these cars hit well in excess of 100 miles per hour.
Scale?
No, actual.
Oh, actual. 100 literal miles per hour.
So scale miles per hour is more like 500 miles per hour.
And we're going to use two. So if one is good for, you said 30, 35 pounds?
25 to 35 pounds.
25 to 30 pounds. And the OpenRC F1, just plastic weight, is like 49-ish.
49, and then we add all of this equipment, we're probably going to be in the 50 to 60 pound range. So two is appropriate.
Not only is it appropriate, it's awesome because we have a chance of going fast enough to be dangerous.
Oh yeah, absolutely.
Okay, these are the motors, and these are by Castle 2028. So I don't know much about RC. Can you talk about Castle and what they are and why we have these?
So Castle's been making really high-end RC car electronics for a really long time. They were nice enough to work with us. These are currently unavailable pretty much anywhere. So they were nice enough to find two to be able to get to us for this project.
So they're very interested because they want to see this car go fast as well.
Yes, absolutely.
That's amazing. Okay. Well, I guess let's give a shout out to Castle. How would people know Castle?
Hi, I'm Richard Castle.
How would they be able to find them, to talk to them? What should they do? I don't know. I'm looking on stuff. I'll tell you what, there'll be a link in the description.
That sounds good.
Because future us will know exactly where to send people.
That's right.
Okay, motors. We've talked about these motors.
Yep.
They're awesome. They're super strong. Let's just set them to the side. What is next?
So to power the motors are these gigantic electronic speed controls.
So for those who don't know, maybe me even, what exactly is an electronic speed control?
So in relation to the 3D printing hobby, this is basically a stepper driver.
Okay.
It is very close.
Okay.
Yeah.
Okay. Wow. Good job right
Not
there.
nearly as precise, but all it does is pulse the different combinations of these three wires into the magnets inside this motor, and depending on the orientation of the wiring, you can get clockwise or counterclockwise rotation.
Okay, once you related it to a stepper driver, that totally made sense because the stepper driver is essentially pulsing the stepper motor
It's the
to do stuff.
same process. The steppers just use a lot more individual wires.
But rather than trying to be precise in a movement, we're trying to accelerate something like redonkulously fast.
Right. All we care about in this regard is raw power and rotation speed.
So these look a lot more robust
Yes,
than any stepper driver I've ever seen. And I don't know electronic speed controls, so what make these work well with these?
They're large enough to handle the amount of current that these motors are going to take.
They look cool.
They do look cool. They're really well built, and they're actually force air cooled. So on the top of each of these is a fan to cool them.
Okay. Well, stepper drivers usually have a fan in the control box to make them cool.
Same idea, but a little more direct due to the amount of heat that they produce.
Well, that's a heat sink, right?
That is all heat sink.
That's a very large heat sink right there.
Yeah, the entire green section is heat sink.
Oh, really? Because we're going to be running a fair amount of power through these things.
We are.
I would imagine.
Yep. We will see probably well in excess of 60 or 70 amps of power, which...
Amperage. That's a lot.
And 33 volts.
Okay, well, I mean, that makes sense, though, because a heavy car with large motors needs a lot of oomph to get it to go, right?
Right.
Wow. So these are, and one of these pairs with a motor, correct?
One speed controller to one motor.
Okay. Well then what's next?
So next we got to be able to make it turn.
Yes.
That is a really big servo.
I'm used to seeing projects that people do with electronics and whatnot. So there's a guy named Ivan Miranda on YouTube. He built a machine that goes along the sand. So he's got a little servo that moves an arm down to drag in the sand to create letters and stuff. And the servo that I saw on that was this tiny little thing with a tiny little arm. This looks like it's ready for battle.
That servo is one of the heavier servos available commonly on the market. You can get bigger servos, but you actually start having to move into actual machine equipment to do that.
So if we're doing hobby RC stuff and we want to get the biggest, baddest servo there is, this is potentially
This is right up there in that top tier.
That's fantastic.
It also is a giant heatsink.
Yeah, I was going to say, this looks like it needs to dissipate a ridiculous amount of heat.
It does. Most servos only have the 3 wires, the power and the control. This servo is actually large enough. It needs its own dedicated power.
So wait a minute. So then so is there power on this line as well?
There is power on this line. So the black and the red on this will power the internal electronics.
Okay.
And the yellow line is the signal that tells it where it needs to be in rotation.
Okay.
And then these are the power lines for the actual motor that drives the rotation.
That's really cool. That should have no problem being able to turn the car at speed.
No, in fact, without scaling it down, it very well could break parts inside the car.
Could it turn, like if I sat on a chair, could it pivot my chair?
Most likely.
That's fantastic.
Most servos, you can actually manually turn them. This one is geared down so tightly that if you pick it up and you try and turn it, you can't.
I'm scared and excited all at the same time. Okay.
It's going to be amazing.
This looks very interesting right here. This is next. So
okay,
this is the battery, right?
It is the battery. Well, it's part of the battery. One of the cool things about this is all reclaimed, recycled cells out of laptops.
Oh.
And flashlights and everything else that you can think of that's basically battery powered that people carry around.
Yeah.
Those are the same cells that are in almost everything. In fact, they're even the same style cell that's in many of the Teslas.
Well, wait a minute, because there's numbers here. There's numbers written on here.
Right. So when you pull all these cells out of consumer electronics that are deemed disposable, some of them are going to be good and some of them are going to be bad.
Okay.
So what I do is I take them apart and then I charge them and discharge them. And in the discharge process, I measure how much capacity they have. So each one of these numbers is exactly how much capacity is in each battery.
Oh.
So it's really important that when you make a single pack that they are all pretty close. They don't have to be exact.
Okay, well,
but they
this
should all
one-
be pretty close.
This one says 2382. That's milliamp hour, right?
Milliamp hour, correct.
And this is 2497
so
milliamp
they're
hour.
pretty,
so those
they're
are close
pretty
enough.
Those are close enough.
Okay, so that's really cool. So then we are going to custom make our own battery for this?
Correct. And most batteries, when you custom build them, they build them out of this really cool puzzle-like assembly of plastic.
Everything just interlocks.
It does. It interlocks. It's not super robust. Usually you have to shrink wrap them and other things like that to keep them from coming apart.
Okay.
So I can think of a better way to do this.
Well, it seems like this is a perfect solution for 3D printing.
I thought so too.
I know a guy.
I do know a guy.
But I didn't know custom battery creation was such a big thing to where there would be a ready-made solution to hold the cells. This is kind of cool.
Anytime you're prototyping stuff like e-bike batteries or things like that, this is a really easy way to put them together and just get them out and functional.
So this is almost like breadboarding for electronics.
Yes,
And then you
absolutely.
Okay. Oh, cool. And obviously that's huge. Next to the huge servo, next to the huge electronic speed controllers, next to the huge motors. Okay, one of the issues that we had, or that we had talked about before, is that the axle here is not going to work well with 3D printed bushings.
Correct.
And if you look right here, it does look like this bushing itself, it rode that, right?
Yep.
Yeah, okay. Now, I suggested to you earlier, what if we printed the bushings out of something like nylon? And,
Correct.
and you said no. Why is that?
So PLA is soft and nylon is a little more durable. And I suspect that we would have issues with the PLA actually becoming the worn away surface.
Oh, if the axle itself was nylon and PLA bushing, then then it may work.
It may work, but
Because-
you're still going to have a lot of friction, and friction makes heat, and hot
Friction does
plastic
make
makes
heat,
melty
yeah.
plastic.
It does, yeah.
It's not ideal.
No. Okay, so then what's our solution here for this specific problem?
So I think the best thing we can do is actually go to what is originally intended to be there is a bearing. And
And I don't know bearings. So then is this shape something that is a usual bearing? How do we
So-
find out?
what we'll have to do is we'll have to measure the inner diameter and the outer diameter, which happens to be 50 millimeters and 70 millimeters, and it's 25 millimeters wide.
Those seem like really decent bearing
They're
values.
pretty common sizes, so I think we'll be able to find a bearing that is close enough that even with just a little bit of fine tuning on the original plastic parts, we can get ones that work.
Well, good. And same thing with then this bushing as well, right?
Any of the
And for
rotating
the wheels.
surfaces,
Okay.
I think, will have those problems.
Oh, okay. Well, since we're already over here, then this piece right here, that's going to be the, so we have the tire, and then it goes like this. So then this piece right here can remain plastic because it's not turning.
Correct.
It's a structural
There's no
piece.
friction, it's
There's
all
no
structure.
friction. Okay. Don't forget your hat, Robert.
Thank you.
Well, speaking of that sexy hat, the tires that are 3D printed in the flexible material, it's Matter Hackers, it's their flex material, which is great for some applications, but we were worried about traction, right?
Right. It's a relatively firm, flexible material, and I just don't think that it's going to be able to have enough bite to accelerate or turn at any great speeds.
Okay. So then what are our alternatives? I know how to talk there.
We
I'm sorry
could print
about
in
that.
something far more flexible.
Okay.
There are some 3D printed filaments that are really soft.
Yes. Oh yeah, with a really low shore value, right?
That's exactly what we need. We need a lower shore hardness.
What if, because I know the goal was to have the fully 3D printed, which I did, but to make it go at any considerable speed then, is it cheating if we just use a go-kart tire?
No, I don't think so.
Okay.
There are just limitations. In all things there are limitations.
Sure.
So we may be finding one here.
So we could take the 3D printed car with go-kart tires faster.
Correct.
But this is still good for when we first start out, when we want to see movement and we want to just run it around the barn or wherever.
For testing purposes, I think it's perfect.
Okay,
It's,
I like
here again,
hearing that.
prototyping.
It's prototyping. There we go. Perfect. Okay. I was curious too about the fasteners because I know. We'll take this piece for example. On the insides, I mean, where the nuts went in.
Yes.
I used anytime there was a bolt and a nut. I took a standard M3 nut or bolt model and then scaled it up 4x. Anytime I had to interface with a plastic piece, I printed out M12 and then tapped that M12. So if we get some M12 bolts, that should work. But
Yes.
would we?
For
do we just get M12 hardware all over?
For the non-structural stuff, I think you might actually still be okay with the printed screws
Really?
in some locations.
Wow, that scares me a little bit.
Well, what's the worst thing that happens? We break it.
Yeah.
That's fun too.
I mean, I get the feeling it's going to break regardless of what we do.
I have a feeling we're going to go through several iterations of this.
We're on to the gearing though, and this is the spur gear?
That's the spur gear, and this is the pinion gear.
Pinion gear. And this would attach usually to the small motor, and then it would spin this. But that's a little large. And at high speeds, 2 plastic interfacing gears, I mean, we're going to chip teeth like crazy, right?
I suspect these motors will have more than enough torque to just snap these teeth off these gears.
At some point in the future, can we try that just to see?
As long as we can get these to fit on the motors, I don't see why we couldn't at
I
least
love
try
that
it.
idea. Okay, but for what we need, though, we need something that works. And we're not going to use this. We're going to use this.
Correct.
So what are we going to use on the other side? Okay. Oh, it's very similar in size. That's not too bad. But I can see that the teeth then are,
They're very fine.
they're very fine. This looks like GT2 teeth.
They are GT2 teeth. And in fact, these are GT2 pulleys.
Oh, perfect.
That would normally be on a stepper motor.
Obviously, this is wider than the belt width, right?
Correct.
So how does that work on something like this?
So this has a shoulder here to here that
Right.
keeps the belt centered.
Oh, do we just need a shoulder on this?
We're just gonna add a shoulder to this, and we haven't quite figured out if the belt is going to be tough enough, whether we're gonna have to use 2 mounted something like this on the motor and 2 belts. So basically 2 belts.
That just looks all sorts of dangerous.
And what it'll end up being is the motor will fit through here. It doesn't quite fit yet. We're going to have to fine tune that a little bit.
Fine tune. That we use abrasive things that spin really fast to fine tune that.
And then
it's plastic, Robert.
That will go there, and the belt will go around it just like a chain on a bicycle.
Okay.
And as long as everything is durable enough.
So GT2 belt. I know that belt is the kind that drives print heads and moves beds. So is that? I don't know enough about that. Is that strong enough to do what we need?
So there are various grades of belts, but good belts are layers of carbon fiber or nylon fibers or ballistic fibers.
Kevlar?
Kevlar.
Oh, okay. So these are made with things that are going to be super strong.
Sure. They use a belt that is much larger in scale, but capable of transmitting hundreds and hundreds of horsepower in drag racing.
Oh, how many horsepower will we have?
These motors are capable of multiple horsepower.
Multiple, like 2 or multiple, like 100 billion?
I don't have the specifications on them.
Could we dyno our car?
I suppose we probably could.
Oh, this is so ridiculously awesome. I do have one more question. And this very sexy looking piece of electronic equipment in front of us, is this what we're going to use to control the car?
This is what we're going to use to control the car.
This looks like something that you would use to radio control a Tesla, or maybe launch things into multiple things into space or something.
So it's actually a 32-channel radio.
32 channel.
Which is way more than we're going to need.
We're going to need
2.
less than that.
We'll need at least 2.
We need turn and we need go.
We need turn and we need go.
Oh.
So we're going to be well under the requirements. But this is typically used for all kinds of things: airplanes, drones.
Okay.
Pretty much anything RC.
It has a page up and a page down button.
It does. It's fully menu driven. If you flip that latch up,
Which one?
the one in the middle,
Okay.
and then press the button.
Welcome to OpenTX. Engine off. Flight mode. Launch.
It talked to me.
It does, and you can configure all of that for different modes and things like that when you're flying. It will remind you where you're at and things like that. When you power it up, if the throttle's up, it will warn you the throttle's up, so that when you power the drone up, it doesn't come alive in your
and
hands.
by warn me, we're not talking about a little light that goes blip, blip, blip. We're
Right.
talking about a voice being like, "Hello, Joel. By the way, your drone is
Exactly.
not configured correctly." Oh, this is so cool. Well, this is a great update. I know that the car isn't actually spinning down the road really quickly at this point, but we're so close because we have most of the problems figured out. And remember the 2 sheets the 2 pieces at the bottom, right? If we just need to put them together and then do one giant plastic skin on the bottom, because everything attaching to it, then it's not going to fall downward.
It'll be in tension.
Intention. It'll be intention. You and your words, I love it. So from here, the next steps are to remodel this with a shoulder for the GT2 belt,
Correct.
to come up with the final battery configuration,
Yep.
and then I will model and 3D print the holder for the cells.
The end caps, yep.
What's next steps for you then?
So I think we should work on getting the motors mounted to the drivetrain.
So if a motor is mounting to this, and you said, it's going to be mounted almost through here.
Correct.
This is plastic, so how could we mount this motor to this plastic without having it just rip through it?
So let's laminate this with some thin aluminum
That'll work?
and basically turn it into aluminum and plastic cardboard. Because a sheet of paper is weak,
Yes.
and 2 sheets of paper is weak, but 2 sheets of paper with just a little fold in the middle is not weak.
No, it's not.
This will be the fold in the middle.
And that'll work.
This will
Well,
work.
I guess we'll find out, but that seems plausible.
Should work.
Okay. I think we've got a lot of progress here, and I think we're closer than I think we are. I think that, like, I can see the goal or the finish line through the trees or whatever. I mean, it seems like we have all the pieces here for success.
We have almost all the pieces I think that are going to be required. We're still have to find the bearings.
Okay. But that seems like a solvable problem.
It is definitely a solvable problem.
Okay. Find the bearings. Skin the bottom piece.
Skin the bottom piece. Make the custom mounting
Custom mounting for the motor.
for the motors. Get the belt, which is going to be another tricky part
You think it'll be tricky?
because we can't use a fused belt because I don't think it will have the strength and tension. So we're going to have to use a prefab belt that's one continuous piece.
Ah, okay.
So we have to work within the constraints of what we can get in belt size and the mounting.
Okay, but that seems like a solvable problem.
It is absolutely
That's
solvable
something
problem.
that's made. Someone solved that problem long ago, and we're just going to piggyback on their solution.
Yes, for sure.
Okay. Wow. Well, Robert, I think we're super close. I want to just thank you, man. I appreciate this more than you know, because RC stuff, I've always been intrigued by it, but I don't have that deep knowledge. If knowledge were the sea, it's very shallow.
It is super fun.
But it seems like you have deep knowledge in this, and I'm excited because custom battery, large motors from Castle, electronic speed controllers from Castle. This servo is just nuts. This is nuts.
It is very, very large equipment. This is much larger than most people will ever get to in the 3D hobby, or in the RC hobby.
That's perfect. Well, you know what? I just want to say thanks to everybody for watching the video, and if you made it this far, you're awesome. We're getting closer to getting this OpenRC F1 running, and once we have everything worked out, then we'll make it go. But until then, we're going to be working hard to get it put together. Big thanks to Robert for helping out again.
Always happy to help.
Well, this won't be the last time you help with something like this, because this is a lot of fun. But subscribe if you're not. Ring that bell to be notified of when cool stuff like this happens, or if, like this, look at this beard. Subscribe just because of this beard. Don't forget to hug each other more. I love you guys. As always, high five. Crisp. That's good. I'm going to save that one right in here.